Why aren't superclass underscore init underscore methods automatically invoked? Why did the Python designers decide that subclasses underscore init underscore methods don't automatically call the underscore init underscore methods of their superclasses, as in some other languages? Is the Pythonic and recommended idiom really like the following?
The crucial distinction between Python's underscore init underscore and those other languages' constructors is that underscore init underscore is not a constructor, it's an initializer. The actual constructor, if any, but, see later, is underscore new underscore and works completely differently again. While constructing all superclasses, and, no doubt, doing so before you continue constructing downwards, is obviously part of saying you're constructing a subclass's instance. That is clearly not the case for initializing, since there are many use cases in which superclasses initialization needs to be skipped, altered, controlled, happening, if at all, in the middle of the subclass initialization, and so forth. Basically, superclass delegation of the initializer is not automatic in Python for exactly the same reason such delegation is also not automatic for any other methods. And note that those other languages don't do automatic superclass delegation for any other method either. Just for the constructor, and if applicable, destructor, which, as I mentioned, is not what Python's underscore init underscore is. Behavior of underscore new underscore is also quite peculiar, though really not directly related to your question, since underscore new underscore is such a peculiar constructor that it doesn't actually necessarily need to construct anything. Could perfectly well return an existing instance, or even a non-instance. Clearly Python offers you a lot more control of the mechanics than the other languages you have in mind, which also includes having no automatic delegation and underscore new underscore itself.
I'm somewhat embarrassed when people parrot the Zen of Python, as if it's a justification for anything. It's a design philosophy. Particular design decisions can always be explained in more specific terms, and they must be, or else the Zen of Python becomes an excuse for doing anything. The reason is simple: you don't necessarily construct a derived class in a way similar at all to how you construct the base class. You may have more parameters, fewer, they may be in a different order or not related at all. This applies to all derived methods, not just underscore init underscore.
Java and C++ require that a base class constructor is called because of memory layout. If you have a class base class with a member field 1, and you create a new class subclass that adds a member field 2, then an instance of subclass contains space for field 1 and field 2. You need a constructor of base class to fill in field 1, unless you require all inheriting classes to repeat base classes initialization in their own constructors. And if field 1 is private, then inheriting classes can't initialize field 1. Python is not Java or C++. All instances of all user-defined classes have the same shape. They're basically just dictionaries in which attributes can be inserted. Before any initialization has been done, all instances of all user-defined classes are almost exactly the same. They're just places to store attributes that aren't storing any yet. So it makes perfect sense for a Python subclass not to call its base class constructor. It could just add the attributes itself if it wanted to. There's no space reserved for a given number of fields for each class in the hierarchy, and there's no difference between an attribute added by code from a base class method and an attribute added by code from a subclass method. If, as is common, Subclass actually does want to have all of base classes invariants set up before it goes on to do its own customization. Then yes, you can just call base class _init_ or use super, but that's complicated and has its own problems sometimes. But you don't have to. And you can do it before or after, or with different arguments. Hell, if you wanted you could call the base class _init_ from another method entirely than _init_. Maybe you have some bizarre lazy initialization thing going. Python achieves this flexibility by keeping things simple. You initialize objects by writing an _init_ method that sets attributes on self. That's it. It behaves exactly like a method, because it is exactly a method. There are no other strange and unintuitive rules about things having to be done first, or things that will automatically happen if you don't do other things. The only purpose it needs to serve is to be a hook to execute during object initialization, to set initial attribute values, and it does just that. If you want it to do something else, you explicitly write that in your code.
To avoid confusion, it is useful to know that you can invoke the base _class _init_ method if the child _class does not have an _init_ class. Example. In fact, the row in Python will look for _init_ and the parent class when cannot find it in the children class. You need to invoke the parent class constructor directly if you have already an _init_ method in the children class. For example, the following code will return an error. Class parent. Def in itself, a equals 1, b equals 0. Self.a equals a. Self.b equals b.
How did you